In today's activity, we are going to be learning how to complete the square. Now, this is part one of a two-part series in completing the square. Our objective for today, as seen in the know and do, solve quadratic equations by completing the square. When we're all done with this, you'll be able to do a problem much like what is seen here in the do, right here. For our wicker know and do, the meaning of the word square or perfect square. Our essential question for today is, what is a square or a perfect square? All right, let's go ahead and begin the instructional material. Before we begin today, I want to relate the toy that we see right here to solving quadratics. Now, when you were a child, you had to put the star shape in the star hole, the triangular shape in the triangular hole, and so on and so forth. Well, when it comes to solving for quadratics, we're going to do something very similar. Sometimes the problem will factor, and if it factors, you can solve it using the zero product property. Other times, the problem will not factor, so we will have to use another method. Well, today's activity, completing the square, will teach us how to solve for a quadratic when a quadratic equation is not factorable. Going on, this is a quick review of what we've done so far in solving quadratics. You learned how to solve quadratics using graphing, and you could take a look at the graph, and from the graph you could identify the different zeros of the function. For example, let's say that you had, let's say f of x is equal to x squared. And when you went through here and you plugged in, say, let's say -2, -1, 0, 1, and 2, and you plug that in for x, you realize this came out to be 4, and 1, and 0, and 1, and 4. Okay, well, looking right here, you could see the zero of the function is right there. So now, what does that mean? Well, that means that when we graph this function, that parabola is going to come down like this. It's going to cross right there at the point 0, 0. That means that this point right there is the zero to the function. So you can identify the zeros of the function through graphing and through creating a chart. Now, another way we solve for the quadratic is through factoring, and these were the steps that we used in factoring. Okay, now this slide should already be in your flip chart, so make sure you have this slide in your flip chart. Prior to going into the process of completing the square, we're going to use a process called extracting the roots. Okay? Now, extracting the root is when you can isolate the x squared and you can take the square root of both sides. So, to summarize, many quadratic equations contain expressions that cannot easily be factored. For equations containing these types of expressions, you can use the square roots to find the roots. Okay, so that's what we're going to do, and this process is called extracting the root. Now here's what I'm talking about when we talk about extracting the root here. Let's say that I have x squared equals 15. Well, in this case, we take the square root of both sides. Now remember, when you take the square root of both sides, you will get two solutions, both a positive and a negative one. Now maybe you're asking, why are we taking the square root of both sides? Well, how do you undo a square? Well, the square root. So then you're left with x is equal to plus or minus radical 15. Now this will work with all numbers, not just a number like 15. It'll work with any a value. Now there is one restriction to this though. Notice here, the a must be a non-negative real number. Okay, so in other words, you don't want to take the square root of a negative number. That is something we're going to learn about at another point. Okay, let's take a look at a problem here. Now, in order to do this type of problem that I see right here, I have to isolate the x, okay? Well, I need to get this right here all by itself. So how do I do that? Well, you see this x, this 11 right here? Well, we can subtract 11 to both sides. So if I go minus 11 to both sides here, then when I do that, it will give me 4x squared equals 48. Okay, now, is the x squared isolated? Okay, well, let's look. Is this isolated yet? Well, no, it isn't. I still have that 4. So what do? Let me get rid of that little piece that I drew around there. How do I get rid of that 4 in front of there? Well, what's the opposite of timesing by 4? Well, dividing, yes. So we're going to divide both sides by 4. And in doing so, now I have x squared is equal to a 12. So now look here. My x squared is isolated. So now at this point, I will take the square root of both sides. And in doing so, that will give me x squared equals the square root of 12. All right, now don't forget, because you took the square root of both sides, make sure it's plus or minus, okay? Now, from here, we just need to simplify the radical 12. Well, how do I simplify that? Well, let's think here a second. The square root of 12, is there a perfect square in there? Well, yes, 4. So 4 times 3. And then the square root of 4, of course, is 2, leaving us with x is equal to plus or minus 2 radical 3. Now, when you're done, we did solve for x, so let's go ahead and put it in set builder notation. So put your colon there, put your x there, and put it in set builder notation. In this next problem, we're going to see another scenario. Notice I'd like to isolate the x, but I have x here. In the linear term, I have x here in the quadratic term. That's not possible to isolate the x unless I do something else. Okay? Now, here's an example here. Notice, look at this here. Does this quadratic equation, is that quadratic equation there on this side? Let's just focus on the left side here. Is that a perfect square trinomial? In other words, does this have a perfect square? Well, yes, x. Does this have a perfect square? Yep, it's 6. Now, if I were to take that 6, that perfect square here, and this perfect square there, and I were to multiply it together, that would give me 6x. And then if I were to take that and times it by 2, that would give me 12x. Now, I want you to see something. What is right there? If it happens to be what is right here, then that means this trinomial is called a perfect square trinomial, which means it factors, and it factors into a perfect square. So, what does that mean for us? What does it do for us here? Well, that means that I can factor it. So let me get rid of a few of these things real quickly here. Okay, so that means here I am going to factor it here. So it's going to look just like this. And notice this 6. What's the perfect square? Well, we said it was 6. So what's going to happen is I'm going to put the perfect square as good. It's going to be x plus 6 times x plus 6, just like that. Now, I can write this as x plus 6, the quantity squared. Now, after doing that, now look here, I have a quantity squared right there. And having a quantity squared, that means I can take the square root of both sides. In doing so, then I will get just x plus 6 is equal to the square root of 28. And then don't forget to put the plus or minus here in front. Now I'm almost done with this problem. At this point, I can subtract 6 to both sides. And in doing so, now I have x is equal to negative 6 plus or minus the square root of 28. Now, I'm almost done. The only thing I have left is I need to simplify this radical 28. Is there a perfect square in 28? Well, if you said 4, you are right, because 4 times 7 is 28. So when I simplify that, that's going to make it so I will have negative 6 plus or minus. Now, here, let me write this out here. I'll have negative 6 plus or minus the square root of 4 times 7. The square root of 4 is 2, so that gives us negative 6 plus or minus 2 radical 7. Now, the last thing I need to do is I just need to put my colon in place and put it in set builder notation. Okay, let's take a look at one more problem before we wrap this up here today. First of all, looking at this here, is this a perfect square trinomial? Well, I would say, let's see, x squared? Yep, perfect square there, it's x. 16, perfect square? Yep, that's a 4. Now, if I take that 4 times that x and double it, does that give me 8x? Yep, it sure does. So that tells me right off the bat that this here is going to factor into x plus a 4 equals 49. Or I could write it as x plus 4, the quantity squared, equals 49. All right, now I need to take the square root of both sides to get rid of this quantity squared. In doing so, now I have x plus a 4 is equal to plus or minus, and I have the square root of 49. Well, what's the square root of 49? If you said 7, you are correct. Now, let's go ahead and subtract this 4 to both sides. So now I have x is equal to negative 4 plus or minus a 7. So now let's think about this here. I have negative 4 plus 7, which means that's going to be x equals 3. I have negative 4 minus 7, which means x is going to equal negative 11. So my two solutions, x such that x is equal to a positive 3 and negative 11. Okay, folks, well, that's going to wrap it up for today. I will see you in class.